In chain surveying, only linear measurements are made in the field. Triangle is the only simple figure that can be plotted from the lengths of its sides measured in the field. Therefore, the principle of chain survey or chain triangulation is to provide a skeleton or framework consisting of a number of connected triangles. After completing this module, you will be able to apply the procedure of triangulation to estimate the extent of land, describe the methods of computing the chain angles. Let's observe the step-by-step description to measure the area of the given field by chain triangulation. As a first step, gather these instruments: a chain of 20 or 30 meters, arrows as required, ranging rods as required, and pegs as required. Identify the field whose area is to be measured. Now, establish the survey stations. As you know, the survey station is a prominent point on either at the beginning or the end of the chain line. Look, in this field, A, B, C, D, and E are the main survey stations. You know that any line joining the main survey stations is called a main survey line. The biggest of the main survey line is called the baseline. Mark the baseline as it helps you to take command of the field. That is, it acts as a reference line. Mark this baseline with chalk powder. Divide the area into triangles. Note that with the baseline, one triangle EDC is already formed. Using the chain, if you join the points A and C, you will get two more connected triangles, CAE and CAB. Look, this framework now gives three connected triangles. One is A1 connecting EDC, the second is A2 connecting CAE, and the third is A3 connecting CAB. Using the chain, measure the lengths of AB, BC, CD, DE, and EA. The length of AB is 14 meters, BC is 12 meters, EC is 21 meters, AC is 18.5 meters, DE is 9 meters, and CD is 12 meters. Now, calculate the area of each triangle using this formula. S for triangle ABC is equal to the sum of the lengths of each side of ABC divided by 2. That is, S is equal to AB plus BC plus AC divided by 2, which means S is equal to 14 plus 12 plus 21 by 2, which is equal to 23.5. So, substituting this S and lengths of AB, BC and AC gives the area of triangle ABC as 80.11 square meters. Similarly, for triangle EAC, the area is 92.49 square meters. Finally, for triangle DEC, the area is 45.35 square meters. Once you have the area of each triangle, you have to sum up the areas of all triangles. Here, we have areas of three triangles, A1, A2, and A3. When we sum up the area of these three triangles, A1, A2 and A3, we get the area of the given field, that is, ABCDE, as equal to 217.95 square meters. Assume that there is a pond in this field. Using a chain, you cannot form triangles in this field with a pond. In such a case, the angles between adjacent sides are fixed by chain angles, either by tie stations or a cord. Let's understand the formulation of any one chain angle for the field ABCDE using the tie stations. On the main survey line AB, fix the tie station T1 at some distance, say 3 meters from A. Now, hold the handle at the main survey station A and fix another tie station T2 on the opposite main survey line AE, but at the same distance as above. In this case, it is 3 meters. Use a tape or chain to measure the distance between T1 and T2. Measure the distance between T1 and T2. Now, after computations, the determined angle T1-AT2 is said to be the chain angle. The principle of chain survey or chain triangulation is to provide a skeleton or framework consisting of a number of connected triangles. The steps for estimating the extent of land using chain triangulation are: Step 1. Gather the instruments. Step 2. Establish the survey stations. Step 3. Establish the baseline. Step 4. Divide the area into triangles. Step 5. Measure the length of all lines. Step 6. Calculate the area of each triangle. Step 7. Calculate the sum of the areas of all the triangles. The two methods of computing the chain angles are by using tie stations and cord.